Okay, so this is lesson 4. We're still in unit 6, physical behavior of matter, and we're going to just talk about some phase changes here. The objectives are to identify parts of the phase change diagram, the heating and the cooling curves, and determine whether a reaction and or phase change is either exothermic or endothermic. So let's look at our phase changes here, and when we go from a gas to a liquid, that's actually going to be called condensation. Okay, so this is like when you're taking a shower and the steam rises from the shower and then eventually cools and then goes back down to a liquid and leaves droplets of water on your mirror. When we go from a liquid to a solid, okay, we're thinking about any type of liquid, water especially, but liquid to a solid is going to be freezing. Okay, now when we go directly from a gas to a solid, it's the opposite of sublimation, which is called deposition. And think about depositing something. So it leaves deposits behind. Okay, now let's go the other way. So for the warming up, if we're increasing our energy or adding heat energy, we're going to look at going from a solid to a liquid, which is going to be called melting. When we go from a liquid to a gas, that's called evaporation or vaporization. And like I said before, when we go from a solid all the way over to a gas, that's going to be called sublimation. All right, so notice when we're going up from solid through liquid to a gas, we are absorbing or gaining heat energy, and then we are taking away energy as we're going the opposite direction, which is cooling a substance. So phase changes are classified as either endothermic or exothermic. Endothermic is when a system absorbs or takes in heat energy, so that would be going from solid to a liquid to a gas. That would be an endothermic system. And exothermic would be where we would see the cooling curve. The system gives off heat energy and it's actually being taken away. So we're going to look at this graph to help us answer questions. Again, this is a heating curve because it's going up. Okay, so temperature versus time. At what temperature will this substance boil? So we have to say to ourselves, and this is what I told you guys to do during classes, to mark where your points are. Okay, so here is the boiling point, and here is your freezing point slash melting point. Okay, so it says at what temperature will it boil? Well, we're going to look at this point and go all the way across, and we see it's 90 degrees Celsius. Next question says at what temperature will this substance become a liquid? So when we look at our phases and we say, okay, this is a solid and a liquid here, this is all solid. Here is a liquid. So at this point, this is when it actually will become an entire liquid. So that will be at 60 degrees. Or actually it's 55 degrees. Sorry. Okay, so at 55 degrees, we will see that it will turn to an all liquid there. Next, between 55 and 90, so we're looking at that point, 55 and 90 degrees, so we're looking at an incline. It asks about kinetic energy. So what is happening here? The kinetic energy is increasing. And at that point, we say that the particles are starting to move much more rapidly. And then at 90 degrees, exactly at 90, the potential energy of the substance is now doing what? It's going to start to increase because our kinetic energy is going to remain constant. As you can see, it stays at 90 degrees for a significant amount of time there, a few minutes. So we're going to say that the potential energy is increasing here. Okay, so to sum up this lesson, we're going to just look at exothermic and endothermic and finalize our lesson for right now. So the definition of exothermic is a system's releasing or giving off heat energy. So here are your characteristics. If we're looking at something in a crucible, it's going to be cooling and energy is going to be given off, so it's exothermic. Those examples would be freezing or condensation. Non-examples would be the opposite, so we would put in here melting and boiling. Another term to use for boiling is vaporization, like I said on the last slide there. Okay, so vaporization. And then if we look at endothermic, endo to absorb or gain heat energy. If you look, we would heat something up in a crucible, and it will allow for the substance to either melt or vaporize. So examples would be melting and boiling, and non-examples opposite of those, freezing and condensing or condensation. Okay, so we're actually done with this lesson, and what I'd like you to do is just review your notes, be ready for a short little quiz when we come back. Okay.